All right, the last section for 15.4 states, model with mathematics. Mr. Cortez uses the table below to organize his findings before he enters information in the database. Place a check mark if the polygon has the given property. So now we're classifying our properties based on our words. Quadrilateral, kite, trapezoid, parallelogram, rectangle, rhombus, and square. So, of these, let's see, 2, 4, 6, 7 categories, how many of these are four-sided figures? I agree. All of them are four-sided figures. So they all have the characteristic of being a four-sided figure. Does a quad necessarily have opposite sides parallel? No. Does a kite necessarily have opposite sides parallel? No. Does a trapezoid have opposite sides parallel? No. Does a parallelogram have opposite sides parallel? Yes. Does a rectangle have opposite sides parallel? Yes. Does a rhombus? Yes. Does a square? Indeed it does. Now we're going to look at opposite sides being congruent. Are our quadrilaterals, do they always have opposite sides congruent? No. Do kites have opposite sides congruent? No. Do trapezoids have opposite sides congruent? No. Do parallelograms have opposite sides congruent? Yes, that is a characteristic of a parallelogram. Rectangles have opposite sides congruent. Rhombuses, their opposite sides are equal to each other. Squares, the same thing. Opposite sides are equal to one another. All right. Opposite angles congruent. So, do quadrilaterals have opposite angles that are congruent? Not necessarily. What about a kite? Nope, not necessarily again. Trapezoids? Nope. Parallelograms? Yes, their opposite angles are congruent. Rectangles? Well, I hope so because they're all 90-degree angles. Rhombuses? Yes, their opposite angles are congruent. Squares? Well, seeing how they're all 90 degrees, I'm assuming that opposites are congruent. Here we have characteristics that the diagonals bisect each other. Quadrilaterals? No. Kites? No. Trapezoids? No. Parallelogram? Yes, their diagonals bisect each other. Rectangles? Yes, their diagonals bisect each other. Rhombuses? Yes, their diagonals bisect each other. And squares? Yes. Consecutive angles are supplementary. Now remember, that means that consecutive angles sum up to be 180 degrees. Is that necessarily true in quads? No. Kites? No. Trapezoids? No. Parallelograms? Yes. Rectangles? Yes. Rhombuses? Yes. And squares? Yes. Diagonals are perpendicular to one another. Is that necessarily a characteristic of a quad? No. Is it a characteristic of a kite? Yes. Is it a property of a trapezoid? No. Are diagonals necessarily perpendicular in a parallelogram? No. What about in a rectangle? No. In a rhombus? Yes, that is a characteristic of a rhombus. Squares, the same thing. They do hold that property. Quads, do they have 4 right angles? Not necessarily. Kites, nope. Trapezoids, not hardly. Parallelograms, 4 right angles? Not necessarily. Rectangles, yes, they must have 4 right angles. What about a rhombus? No. Squares? Yes. 4 congruent sides. Is that a property of a quadrilateral? No. What about a kite? No. Trapezoid? Nope. Parallelogram. Do they have to have 4 congruent sides? No. Rectangle? No. What about a rhombus? Yes, that's part of the definition of a rhombus is that they have 4 congruent sides. And the same thing with a square. That is part of its definition. Okay? Exactly 1 pair of opposite sides parallel. The only one that classifies under is a trapezoid. They must have 1 pair, exactly 1 pair of opposite sides parallel. On to your next set of questions.